Another elementary sorting algorithm is the selection sort. The selection sort a little bit resembles insertion sort as we have just seen. What you need to do is at each iteration, you look for the minimum of the sequence and then you place it in its correct position. So you select the minimum and you actually swap it if it is not the same value with the leftmost position. So you start from position 1, okay, and you find the minimum of the entire list and you swap it by the first position so that the minimum goes in the first position. And then you go to the second one. Whatever remains in the second, in the right hand side, you find the minimum of the remaining elements and you swap it with the second position. So the second minimum goes to the second position. Simple as that. Okay, let's see how it works. Now for the first position, you find the minimum of the entire sequence, which is 1, and therefore you swap these two. Okay, so this is the first position, this is the minimum position, you swap them, 1 is placed here, and now 1 is in its final correct position. Okay, so this part is now sorted. And then you look at the second position, and you will swap it with the minimum value of the remainder, the unsorted portion. So that is 2, the minimum of the unsorted portion. So you actually exchange these, you swap these. Okay, so 2 and 5 are swapped. Okay, 2 comes here, so this portion is now sorted, and this part not yet. And then at the third position, you look for the minimum of the remainder, which is in fact itself, so you don't need to really swap it. Okay, so it immediately becomes in its correct position. And now the sorted part is these 3, and you take the next position and find the minimum of the remaining of the sequence, which is 4. Okay, so you swap them and 4 becomes at its correct position, and 5 finally, and since it's by itself, it has to go at the end. Okay, so in this way the list is sorted. It's a little bit similar to insertion sort. It's not the same, but logic-wise, it's not that much different also. Of course, implementations could be different. Another important method is the so-called bubble sort algorithm. And here you go by pairs, the consecutive pairs, and you actually swap if they are in incorrect order. Okay, so you start from uh, this indicates the end of your scan, and the inner loop here is going to indicate your forward scan, and you look at pairs, and if they are in incorrect order, you swap them. Let's see it in operation. Okay, so at the end, nothing is sorted, so you just take the first pair. Here you see I indicates 1, and sorry, j indicates 1, and I will indicate n minus 1, and n here is the number of numbers in my sequence, so that is 4. So I'm going to scan j up to 4, which means I'm going to look at this pair and then this pair and then this pair and then this pair. Well, I do not have a pair here, so that's the reason this should go all the way to n minus 1. Okay, so looking at the first pair, 2 and 5, they are in correct order. I'm checking them, but they are in correct order. So I go to the next pair, 3, 5. Now they are in incorrect order, so I have to swap them like so. And then I look at the next pair, 5, 1, again in incorrect order, so swap them, 1, 5. and then I look at 5, 4, again in incorrect order. So swap them. In this way, you see 5 is placed here and 2 is placed here. Now, well, 5 happened to be in here, but what is important here, since I'm pushing the smaller ones to the left, actually in my first pass, I have guaranteed that this position is now has the correct value it has to have at the end of the execution of this algorithm. So you see I will be decremented to n minus 2. So in the next pass, I'm going to start from 1 again, j equals 1, but I'm going to check my pairs up to this pair. I will not look at here. I'm not going to check this pair because now I know 5 is in its correct position. I don't need to really touch it. Okay, so this here, n minus 2, is going to be the upper bound for the indicator j. So in your second pass, you start from the beginning again. You check 2 and 3, this pair, and they are in correct order. So look at the next pair. As you see, 5 is now green, indicating that it is in its correct position. So 3 and 1, this pair, it's in incorrect order, so swap them, comes 1, 3, and then you look at the next pair, 3 and 4, they are in correct position, so you are done. And in this case, now 4 has been placed at its correct position. Okay, so this part now is sorted, and I don't need to check them. So I don't need to check this pair, and I don't need to check this pair. I'll go up to this, and that is due to the fact that I now has become n minus 3. Okay, so again, you start from j equals 1, and you check this pair. 1 and 2, they are in incorrect order, so swap them, 1, 2, and then you look at this pair, 2 and 3, in correct order, so you don't touch them, but the loop has ended now. Okay, so up to this point, now this part is sorted, this part not yet. Okay, so 3 is now green, and then what is left is this pair by itself. It's the final pair, and 1 and 2, they are in correct order, so I do not swap them, and that is the end of the algorithm.